Hello everyone, my name is Rohan Rajput. I'm a senior data scientist at Headspace. Today, we will be talking about prompt-based recommendation system, a new era of personalized experience. So, in today's agenda, we'll first talk about what is LLM-based recommendation system. We'll go over some basic foundation where we'll discuss about what is recommendation system and how we can use prompt engineering to upgrade our next generation of recommendation system. These recommendation systems comes up with their own shortcoming. So we'll be discussing about importance of fairness and bias in recommendation system, especially LLM based recommendation system. And we'll try to address some of this shortcoming with some of the proposed solutions. And we'll conclude this presentation with ongoing efforts and future direction. So let's start. So what is LLM-based recommendation system? So before talking about LLM-based recommendation system, first, as you all are in prompt engineering conference, you all know that what is LLM system. The LLM system are machines that are trained on vast amount of text data, and they are pretty good at predicting next words in a sequence. These are the common examples of LLM systems: ChatGPT, Google Bard, and recently Facebook Llama. Now, let's dwell into what is recommendation system. A recommendation system is a subclass of information filtering system. That means they help us to process information using historical user and item data, and it helps in user decision making. So for example, whenever you open Amazon website, you see recommended product for you. These recommended product comes from various analysis of historical data done by machine learning systems that actually gives you recommended products. Similarly, we see Netflix, which is an online streaming service, produces these various what we call horizontal shelves that actually help us to recommend various content on the screen. Same goes for the news article. It's a personalized curated news for us provided by Google using lots of user item interaction data. Now, what is prompt-based recommendation system? So, so as we have already know that what is a LLM system and what is a recommendation system. So there is a new field emerging today. It's called LLM-based recommendation system. And because a vast amount of recommendation systems work on some sort of sequential data. So for example, there is whenever you watch a movie on Netflix, there is some kind of uh, temporal order you follow when you watch a movie, right? You on Monday you watch something, on Tuesday you watch something, and similarly for the week you create like your own uh, personalized timeline, right? It when we use collaborative filtering, we can utilize other users' data to curate a personalized timeline for you. Now, when we deal with this kind of sequential data, we can actually use the sequential data to generate next, similarly like a LLM model where we predict the next word in the sequence. Similarly here, using your historical item interaction, we can actually predict what you will be watching next. So uh, we can divide these LLM-based recommendation system into two tasks. Like first is the prediction task, and another one is the generation task. And the prediction task, right? So we can see here that we can train a model which can be like one of these like model that can help us to predict next top K predictions for you. So If you see this top left corner, like this example, based on the movie history, please recommend 5 candidates of the movie that user might be interested, right? So our system can actually generate like 5 candidates for us. Similarly, we can do a rating prediction, means that this is the historical rating given by this user to these movies. Can you suggest me for this new particular movie, what could be a, like, rating from 1 to 10 points? And it can, like, suggest a rating for us. Now, these are like prediction tasks. Similarly, we can also do generation tasks. Generation tasks are useful where we want to, like, interact user, or for example, in a conversational recommendation system where a user is asking to a system that, because I recently watched this movie Interstellar, please recommend something to me. And based on like user data, this conversational system actually generate like some recommendation for this particular user, or can ask like more clarifying questions to this user to to recommend some movie to them. Similarly, we can also incorporate explanation to recommendation system that uh, so this new we got Father 2 is recommended for a user who has recently watched this thing. So we can actually ask that why this new movie was recommended to this particular user, and the LLM system can provide us the explanation of why this, but what type of data has been used and why this movie was recommended to users. So there is some kind of explainability we can incorporate in our recommendations. And all of these things, if you see, like, they are using like some kind of prompt to generate recommendations. Now there is a one research done by University of Rotterdam where uh, they proposed this P5 model. This P5 model is very similar to the T5 model in transformers. Uh, the difference is that here we are talking about prompt-based recommendation system. So here, this is like an example of multi-task recommendation system where it can use like this sequential to sequence to sequence framework to generate multiple types of recommendation. So let's see here. On the top, you see that if we want to do like a sequential recommendation, like we can actually give like a sequence of user ID or item ID to recommendation system and ask it like what is the next ID predict for the user. Like similarly, we can do rating prediction, explanation generation, review summarization, direct recommendation, right? Or zero sort generalization. Here, what we want to do that, like, we have uh, some information metadata available for this particular user, and using this metadata and this prompt, can we inject this prompt to uh, generate some recommendation. So this is like one of the framework is proposed by uh, University of Rotterdam. Uh, Similarly, there are like some problems we found in like this kind of prompting. So no system is perfect solution. No solution is a perfect solution, and there are like some problems we have to solve before these systems can become reality, right? Uh, One of the thing we have seen that uh, there are two types of prompting we can do, right? So there is a wha- there is a one method is called like a point-wise prompting, and another is like a list. Like, so there is a point-wise approach and list-wise approach. And what do you mean by point-wise and list-wise approach? In the point-wise approach, right, you can actually pass a passage. You can give a query and ask like a binary solution from from the LLM system. So you want like a single definite answer that in the form of let's say Boolean yes and no from this LLM system. So another one we can do is the list-wise approach, right? In the list-wise approach, we actually give like a certain uh, options to LLM system and ask it to rank. So let's say in the first example, we give like, entire user history, or like some sort of user history generated by some kind of prompt system. And we ask a query that using this particular metadata, will you recommend this movie to this user or not? And the system will say yes or no. And the next one, you can give like, okay, I have like this five option for this user, and out of these five option, what particular movie, like, give me the ranking on which like you would want to recommend this user this particular movie, right? And the LLM system can generate this this twice, the ranking for us that help us to recommend to our user, right? There are some problems in this approach. Obviously, in the point wise approach, like we have like the calibration problem, and in the second, like this is like the experimentation output, right? So, what is the output generated? Like, what is the output uh, observed by these researchers in this particular paper? That there are like in the list-wise approach, there is like lots of uh, inconsistency, or like there are other phenomena observed in this uh, list-wise approach. So one of them, like, sometime the LLM only output the partial list. That means like it sometime omits certain elements from the list when it was generating the output. It refused to perform, like it refused to give like any kind of ranking in some cases. There is like lots of repetition, like, and also inconsistency. Sometimes like the same prompt they were giving uh, some ranking, but if you change a little bit of information, it just completely changed the uh, ranking of the list, even though there was not substantial changes in the metadata, right? So there are still like lots of uh, uh, hurdles we have to solve before like uh, using this system in the real world solution. So these are like all the research problems, open research problems we have. And these are like, I would fairly say like these are like technical problems for now, right? To build this system. There are some more important problems that we will be seeing that can happen like in this LLM based system. So one of the important aspect in LLM based system is fairness and bias. So when when we incorporate these systems, like LLM system itself, like because they are trained on like vast amount of uh, text data, and historically there were like some of the bias and fairness problem was uh, available in those data set, that actually sometimes reflects in the output of this LLM system. And these LLM, if the output of this LLM system contains these kind of biases, that can amplify it in am- recommendation system also, because this is another like black box machine learning system we are adding to it. So some of the important domains where we should address these problems are like education, criminology, finance, and healthcare. So take example of finance, right? There is a like a there is a some kind of bias can be incorporated like in LLM based recommendation system in finance that rejects someone's like mortgage application. And if someone asks for explanation, it gives like biased like view of someone's like race, or someone's like ethnicity, or some kind of like social factors. So we have to be very careful when using this system in this crucial application. So we make sure that we are not unfairly treated some segment of the group, right? There are like several dimension has been studied in this fairness of ChatGPT paper, where statistical parity, equal opportunity, equal odds, overall accuracy, equality, and counterfactual fairness. These are the several dimension of fairness uh, uh, were studied in this particular paper. I think the overall conclusion of the paper was the chat GPT has comparatively better score than like traditional models like a regression model or a like a multi-layer perceptron model, but is still having some of the issues that should be solved before we use it these systems on a very large scale. Now, uh, continuing this problem, there is another important the big problem is 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 right now persists in LLM system is called hallucination. So in the hallucination, it actually sometimes, provide us like, false or misleading information. So one of the example we can take that like when you actually recommend some kind of product to user and you want your like LLM system to automatically write a product description, right? And it can sometimes like write a like a false description that is misleading to user. So suppose like it's somehow figure out that like if certain phones that are like pretty high selling right now and they contains a certain type of text description that makes its sales more likely to sell, that actually copy that it can copy those like description attributes and try to change like existing description and try to market some of the feature which is not available in the product itself, right? Or like overselling um, some kind of like false marketing in 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 the description of the product. So we have to be make sure that like these type of problem should be properly addressed. Another thing we see in the conversational like AI is that like it can sometimes like solution suggest like unrealistic solution. So for example, if someone is like on a like weight loss journey and the person is using our like LLM based recommendation system, and the LLM based recommendation system starts suggesting some kind of unrealistic diet plan, like stay hungry for like next 12 hours and cut down your like, most of the meals for the day, and like that can lead to like certain kind of nutrition deficiency or like it can also cause several other medical problems. So we should be vetting those outputs properly. We should make sure that our models are not like fabricating information or forging some kind of ideas, right? That are not realistic or sometimes not like appropriate for users. Okay, so what can we do, right? What can we do? These are the all the problems we have discussed, and what can we do about these problems, right? So few of the things we can do. One of the thing we can do is like incorporate some kind of like data and algorithmic solution. Then the data pre-processing, we can do like some kind of bias identification or like some kind of augmentation to remove like some of the biases. We can also make sure that if there is some kind of sensitive attribute present in our data set, we make sure that we properly either remove it or handle it like carefully. So one of the example we see that in recommendation system, when we use data of like movie lens data or insurance data, we see that these are like very sensitive attributes, the distribution of the sensitive attributes in those data set. One, we can see that like in the movie lens data set, we have like gender, age, and occupational data set available. And obviously like we have another set of data here in the insurance data set where the marital status, occupation, gender, all these things are available. And sometimes these actually attributes make more impact than decision making of the system. So we have to make sure that we are uh, properly uh, analyzing those impact of those attributes. One of the solution we can do is like just use like tree-based model to understand that how much like impact this particular attribute is making. But again, like this problem is getting very challenging when we use like these complex LLM based system where we don't have access to this information uh, that clearly there is a very lots of abstract layer that actually goes into decision making, and sometimes it's very difficult to understand why system suggested this particular solution and what are the factors are impacting it. Second is algorithmic fairness. So we can put like some kind of fairness constraint and multi-objective optimization. So for example, like, you when you have a recommendation system, you don't just like uh, try to increase like engagement or click-through rate from that recommendation system, try to have like more multi-objective here. So in the multi-objective optimization, you put like some more objective to optimize. For example, having like low better long-term value, or like increase like serendipity of user and all those things. We should have like some kind of fairness audits and feedback loops to make sure these are like very prominent in recommendation system, especially the feedback loop, because you are influencing your user with some kind of decision making, and that decision making is actually uh, uh, changing the behavior of user, right? And start like putting user in some kind of filter bubbles where user is like a feed getting feedback of this of their own action, right? um, Obviously like explainability and transparent algorithm and user control is very important, that we should have like some kind of control to like mitigate those biases in the database. uh, Diversity and compliance are very important here. Diversity means like sometime we want to make sure that like sometime it might happen that our user satisfaction sometimes get impacted if we increase diversity of the content, but we make sure that we provide equal chances to all the segment of user. So in the music app, right? So if we have like certain new artists, those are not very famous, but we want to give them more chances, like to get not getting stuck by our recommendation system by popularity bias, like just showing popular recommendation to everyone won't work. We have to sometime like increase the diversity of the content, and it could be like very societal diversity or like a within the content diversity. Should follow all the regulatory compliance, especially if we are healthcare solution. Like obviously we should follow like all the HIPAA compliance and different type of regulations around it. So what are the ongoing efforts are in the field of LLM based recommendations, and what are some of the future direction? Obviously, one important thing we can do is like do like user education and monitoring. So sometime it cannot be like well received by our user, that like if we try to increase diversity, our user might complain that why I'm getting this kind of content because I don't follow this kind of, or I don't align with this content. We can educate users on like our fairness metrics. So we can make sure that like all segment of population, whether it's a gender wise or age wise, they treat it fairly, right? We can implement some kind of real time fairness monitoring solution. There are various matrices like uh, uh, let's say uh, entropy or coverage or diversity, right? Uh, uh, there are lots there are lots of metrics available that can be monitored real time to understand that how system is behaving for all set of users. We can do like third party audits and community involvement. So basically it can be like sometimes it's very difficult for to us to understand that if we are like making a fair system or not. So having like an external audit can get us like some kind of unbiased evaluation, and also opening up with a like a public feedback, collecting like feedback from user, or do like user study or user survey to understand that are we making are we correctly measuring our fairness or not. So, in conclusion, the fairness-based LLMs are not just technical issue, but it's like a very societal issue. It needs like a continuous effort from all the set of users and all the set of like different other segments to make sure, uh, right from like from engineers to like stakeholders to senior leaders, we have to make sure that everyone is contribute to make this system fair and responsible. With that, I would like to conclude my presentation. Thank you so much for attending this. If you have any questions, please reach out to me on LinkedIn. This is my LinkedIn profile. And thank you so much. Hope you have a good rest of your day. Thank you.